Hey everybody, John Palucci here. My thesis is titled The Effects of Certain Intermediary Target Materials and Their Proximities to Ballistic Gelatin on Jacketed Hollow Point Bullet Expansion. So bullets come in all kinds of configurations. You have on the top left there, you have the full metal jacket, which is a lead core covered by a copper alloy jacket. Then to the right of that, you have the jacketed soft point, which is a partially covered lead core, and it's intended to expand a little bit. The bottom left, we have a full lead bullet with no jacket. And then to the right of that, we have the jacketed hollow point, which is what we're going to be studying here. And you can see the tip of the bullet has a cavity in it, and it's designed to expand when it hits a soft liquid-based target. So that's a jacketed hollow point bullet. They're usually used in law enforcement. To the right of that, we have fired jacketed hollow point bullets, and you can see some of them expanded nicely, some of them partially expanded. Some of them are severely damaged. They've stripped their jackets, and those are the things you're going to be finding at a crime scene. So now, bullets recovered at crime scenes and autopsies have often struck multiple targets in addition to their intended victims. So right here, we have a damaged bullet that's struck some targets there. Changes occur in the soft metal when it impacts different materials, right? So jacketed hollow point bullets, they're designed to expand when they impact these soft liquid-based targets. To the right, we have an unfired jacketed hollow point bullet, and to the left of that, we have a fully expanded jacketed hollow point bullet. So we're seeing what happens. Then we have this uniform expansion that encompasses the full depth of the bullet's cavity when the expansion is complete. Here are three bullets that expanded very nicely. And when they're fully expanded, they look like a flower, right? So they have these, the tip breaks into these symmetrical sections, and they're commonly referred to as petals. So like the petals of a flower. When bullets in flight, they become damaged or they become filled with material when they strike targets prior to striking a soft liquid-based target, such as ballistic gelatin or human tissue, then you can get expansion failure. So you can see in the middle, we have a nicely expanded bullet. To the left, we have a damaged bullet, right? The cavity was damaged, so it didn't expand. And to the right, we have a bullet that went through denim, and it acquired all that denim in the cavity of the bullet, and the petals did not open up like a flower. Instead, the bullet got flattened after it passed through the ballistic gelatin. So that caused expansion failure right there. The main research question being addressed in this study is, will a jacketed hollow point that has perforated a particular material that subsequently strikes a soft liquid-based target like ballistic gelatin fail to expand due to target materials impacted in the jacketed hollow point bullet's cavity? So that's the one question. Will those materials in the cavity cause expansion failure? That leaves us with some sub-problems. Was the expansion failure due to a destabilized bullet, which we'll talk about in a second? And was the expansion failure due to damaged cavity? Or was it due to velocity loss? So a bullet traveling too slow isn't going to expand. Once I started my experiments and completed one round of them, I also came up with another question, and that is, what about the proximity of the target to the ballistic gelatin, right? So if the targets are up against the gelatin, are they less or more likely to expand than if they're a certain distance away? So the value of understanding these phenomena is essential for shooting incident reconstruction at the C.S.I. level, and also for the forensic pathologist at the autopsy level. And understanding what types of targets a bullet may have encountered between being fired and being recovered at the scene or at autopsy, that's basically the crux of shooting incident reconstruction. So this image here, we have the barrel of a firearm. You can see the twisted metal in there, right? That's cut into the barrel. That's called rifling, right? So that when that bullet passes through there, it gets spin imparted on it, and that stabilizes the bullet. Just think about throwing a football. So now when a bullet perforates a target or ricochets off a target, it can become destabilized, right? You can see that bullet there is, the nose is pointing up. It's not in the nose first orientation. So when something it perforates something or ricochets off something, it'll become destabilized, and it's not likely to impact your tissue or your ballistic gelatin in a cavity first orientation. Now, a damaged cavity can also be a reason for expansion failure, right? When it strikes bullet strikes an object and it damages the cavity, it can't fill with that soft liquid-based material. Another thing we're going to address is velocity loss. So if a bullet strikes a target, it's going to transfer some energy to that target, and it's going to lose velocity as a result of that. So if a bullet is not traveling at the manufacturer's intended velocity when it strikes this tissue or tissue simulant, we could also get expansion failure. Here we have a bullet that's ricocheting off a piece of wallboard. So soft liquid-based targets. We're talking about ballistic gelatin for the purposes of this study. 10% gelatin to water ratio has been found to be very similar to human tissue. Here's a bullet striking that. You can see a large temporary cavity. It behaves very similar to human tissue. In a review of the literature, numerous studies were found where jacketed hollow point bullets are fired into ballistic gelatin to study expansion. That's what they call wounding potential, where they study the degree and the rate of expansion as well as the depth of penetration. A bullet that doesn't expand and over penetrates can be a danger for police officers to use. Like I worked in New York City, if we fired bullets that went through our intended targets, could strike somebody that wasn't intended, and that could be problematic, right? So there is research that directly studies jacketed hollow point bullet expansion in relation to perforating intermediary targets, but they're not commonly found in primary peer-reviewed literature. Some of them have been inspired by bullets recovered at autopsy. Some of these folks here have found bullets, and then they decided to study what caused the expansion to fail. Now, also the FBI, these are not peer-reviewed publications. The FBI and certain ammunition manufacturers also study firing through things like sheetrock and clothing to determine whether or not it can inhibit expansion. And that's to determine really the suitability of these bullets for use for law enforcement agencies. There's also been a lot of research into damaged and destabilized bullets, including jacketed hollow point bullets, and shows that velocity loss can occur, but they didn't really have subsequent impact into ballistic gelatin to study expansion from that point, which is what we're doing here in this study. Also, firearms examiners, the people who put bullets under a microscope to compare them, they want to make sure, if you look at this expanded bullet, you can see that the petals are covering the surface area that these firearms examiners want to use for comparisons. So firearms examiners have used techniques to damage the hollow point to peen it closed, or to put epoxies and things in there to prevent expansion. So when the bullet doesn't expand, they have much more surface area to examine for comparisons. There's also studies on ballistic gelatin. This is the gelatin that I used here. This is clear ballistics. There's 10% ordnance gelatin that the original researchers would mix this gelatin at 10-to-1. Say you got 1 pound of gelatin and you'd have 10 pounds of water to make a 10% gelatin solution. And these are commercially available. I didn't have to mix this up and refrigerate it and do all that. These are much more efficient. You can purchase this. You can actually melt it down when you're done and reuse it. So this is what we used. It was called Clear Ballistics brand gelatin. So the research objectives, the purpose of this thesis study is to study through experimentation how materials from intermediary targets can obstruct the cavity of a jacketed hollow point bullet and cause expansion failure. To effectively study this phenomenon, methods to monitor bullets for the subproblems of bullet destabilization, damage to the cavity, and loss of velocity were designed into the experimentation process. So I used a chronograph and high-speed video to check for velocity loss and also the orientation of the bullet when it strikes the gelatin. These are things that you can't pick up with the human eye. This is the rough setup. I had a firearm. I had 3-level surfaces, a firearm on one surface, the ballistic gelatin on another surface. They're about 10 feet apart, which is protocol for the FBI testing. And in the middle, I would put the intermediary targets and the chronograph. And if the bullets made it through the gelatin, which all of them did, then they would strike a Kevlar panel. And because they'd lost a lot of velocity going through the targets, going through the gelatin, and from that point they could be recovered. So here I am, I'm firing through a chronograph and then into a piece of denim that has a wallet inside of it. It's a denim pocket, and that is affixed to the ballistic gelatin. You can see the very intense lighting because of the high-speed video. It requires a lot of light. And then beyond the gelatin is a Kevlar panel. So I have the firearm, I have the chronograph, I have the high-speed camera and the intense lights. I have the ballistic gelatin. My camera operator is here with just using a laptop computer. And then we have the Kevlar panel. I set up a like a copy stand in the corner here where once the bullets were recovered, they could be brought over here and photographed so that we get their condition immediately upon recovery before they're handled a lot and materials can fall out of the cavities. So that was one of the part of the experiment design. Each shot was given a unique identifier. So each target had its own identifier. So like the wallet was JP1, right? So I used my initials and then a consecutive number. So JP1 was the wallet. The first shot through the wallet was JP1. The second shot through the wallet was JP1A. And the third shot through the wallet was JP1B. Here's the wallet and its contents. It's JP1. Every shot through the wallet starts with JP1. Okay, and that's the pocket that the wallet went into, right? These are things commonly found at crime scenes. People wear jeans, people have wallets in their pocket, right? The wallets have contents in there. So that's my JP1 series. There you can see the wallet that's affixed with Gorilla Tape to the ballistic gelatin. And beyond that is the Kevlar panel. And you can see the light screen from the chronograph actually, and the light source for the chronograph. So I'm going to fire through that into the gelatin. Once I fired through that, this is the back side of the gelatin. Here's the bullet exiting. You can see it's tumbling, it's destabilized, and you can see these little discs, right? These are pieces of the material and the wallet and everything that are all very similar in size. They call that a cookie cutter effect, where the cavity of the bullet actually cuts a small piece of the material out like a cookie cutter. This is the JP2 series. So everything with JP2 is the cell phone that's in a front pocket from a pair of jeans. It's all JP2, right? It's a Galaxy S7 cell phone. And here is that bullet after going through the cell phone and the gelatin and exiting here. Look in the cavity, you can see the pulverized glass in there, right? And behind the bullet, here's a whole cloud of pulverized glass and a piece of the cell phone and perhaps a piece of denim that came out, that's spilling out of the cavity. And then from there, it's going to go and impact the Kevlar panel. This is the JP3 series. It was a piece of wainscoting. It's actually particle board. It's 0.2-inch particle board. So I fire through that. You can see beyond that, just beyond that, there is a piece of canvas. And that was used as a barrier because from the exit side of this particle board, the bullet's going to travel through a chronograph. And I was concerned that debris from the particle board is going to go through the chronograph and skew my readings, right? So that's how the process worked. And there was a little hole in the canvas so that just the bullet would go through and not all the debris, right? So here's the bullet fired through that particle board, and it's going in a nose first orientation. It did not get destabilized by hitting the particle board. Same thing with the sheet. Right, so the bullet goes through the sheetrock, through the chronograph, and here it is now, entering the gelatin. Okay, once again, not destabilized. So I was concerned that these bullets weren't destabilized. I had kind of anticipated that was going to happen. So I wanted to induce destabilization. I turned the target at a 45-degree angle so that it would induce destabilization. You see how the sheetrock is now angled. It's not, I'm not firing perpendicular into the sheetrock. It's at an angle. And guess what happened? We destabilized it. It did not take the same path that the other bullets did. It actually went down, it hit the wood and some of the gelatin, and that bullet did not expand. And the reason it didn't expand was because it was destabilized. So here we have, I also fired some test fires one through bare gelatin, because everything else had passed through something and then the gelatin. So I want to see what a full expansion would look like firing through bare gelatin. And then also because two of my target materials were inside of denim pockets, I wanted to fire through the denim pocket as well. So those are my controls. I had a denim control and a gelatin control. My a priori hypotheses were that the cell phone and the wallet would fail to expand because of material inside the cavity. Right? I designed all these experiments to promote bullet expansion failure. I also anticipated that all the shots through the sheetrock and the particle board would destabilize, so they would also fail to expand. As it turned out, all the bullets fired through the wallet failed to expand. All the bullets fired through the cell phone also failed to expand. But I did notice, contrary to the wallet, the bullet had like a compression type of damage to it from hitting the hard material. That Gorilla Glass in the phone is very, very hard. So that was something that was different from between the phone and the wallet, but they both failed to expand. Bullets fired through the particle board expanded significantly. Bullets fired through the sheetrock expanded significantly. So these are the bullets fired through the wallet. I threw a unfired bullet in there for reference. You can see they're a little flat looking, right? So they did not expand. There's some fibers in the bullet's cavity, but and in the middle, here's the recovered bullets. But when you see the bullets exiting the gelatin, they are not flattened like that. So the flattening was a result of my bullet recovery system. After the bullets exited the gelatin and hit the Kevlar, they flattened like that. And here's the wallet with its contents and the jeans, all with ballistic damage from firing those JP1, JP2, JP3 shots through it. And you can also see where the control was fired through there, the denim control and into the gelatin. So this is the JP2 series, the bullets fired through the cell phone. You can see pulverized glass and denim inside the cavities of these bullets. And if you look at the top, you can see how they're bulging at the top from compression. So that's a totally different look than the bullets fired through the wallet had. So something much different happened here. As you can see, once again, the destabilized bullet, the cavity, the compression was present when it exited the gelatin, so it's not an artifact of striking the Kevlar panel. And here's the pocket with the ballistic damage to the cell phone and to the denim jeans. The JP3 series, all those bullets struck the gelatin in a nose first orientation, so they were not destabilized, and we got excellent expansion from the JP3 series through the particle board. Same thing with JP4, all hit nose first, except of course JP4C, that destabilized one, you can see all the way to the right, and we once again had excellent expansion there. The bullet fired directly through the gelatin expanded very nicely, whereas the one fired through the denim covered gelatin did not expand very well. You can see very significant differences there. As far as the velocity loss goes, it was not a factor at all. The readings, the chronograph readings at the top, they're in feet per second. They were taken from when the bullet left the muzzle of the firearm. So it was in between the firearm and the wallet or the cell phone. So it's basically directly from the firearm. And the one on the bottom is the JP3 and JP4 series, where I took the measurement after it went through the particle board and after it went through the sheetrock. You can see very little velocity was lost. And also by the expansion, we know that velocity loss was not a factor. So after doing this testing, I started scratching my head a little bit when I was trying to get some data together from these bullets. And I wanted to go back in and do some more testing and change the proximity of these targets to the gelatin. So the sheetrock, instead of being 7 feet away from the gelatin, I wanted to put it flush up against the gelatin and see if that would change anything. And also move the wallet, so the sheetrock and the particle board would be up against the gelatin, what we call shored. And the wallet and the cell phone, I was going to move it further back and do a new round of experiments in that frame of mind. So my a priori hypothesis for these experiments was that the sheetrock and the particle board would be shored against the gelatin, and I believe they would fail to expand, right? And I also believe that the cell phone would fail to expand, even though it's 7 feet away from the gelatin now, because of the damage to the cavity. I wasn't sure about the wallet. I thought maybe the material in the cavity would cause expansion failure, or maybe not. I wasn't really sure. I didn't really formulate a hypothesis on those. So I used the same wallet and cell phone as I did in phase one. I had a new piece of 2-inch particle board that I bought from the same supplier. So very, very similar. The 2-foot by 2-foot pieces of 1/2-inch sheetrock were from the same source as the phase one experiments. So everything is very, very similar. This time I fired 3 shots through the bare gelatin and 3 shots through the denim covered gelatin. So everything was very, very similar, right? I also moved did another set of shots where I moved the same exact pieces of sheetrock 7 feet away. That was like a retest of the phase one testing. I didn't use the chronograph. The chronograph wasn't working for this, and the high-speed video was not available. So for continuity, I used the same numbers, the same series. So anything with JP1 has to do with the wallet. So this time in phase two, it's JP 1.1. The cell phone is JP 2.1. Okay, particle board 3.1, 4.1. All right, here's the sheetrock up against the gelatin. So the bullet's going to come from the right, go through the sheetrock into the gelatin. That's what this setup looks like here, right? A little different. Don't have all the camera equipment. This is the wallet in the denim pocket. It's a new pocket, but the same wallet. And I have a piece of foam board that I cut a hole in for the bullet to go through. So the bullet's going to go through the wallet now 7 feet away from the gelatin, whereas before it was up against the gelatin. So firing through the denim, I put the denim over the gelatin, just denim over bare gelatin. And I had the same results as I did the first time. I had very minimal expansion, except for the third shot through the denim, which the bullet went through a seam. And that caused it to fill with denim and actually fail to expand, right? The gelatin here, we have very nice expansion from 3 shots through the gelatin. Now you can see, you can compare the differences here. The phase one testing, shots through the wallet, all the JP1 series and the JP 1.1 series, the ones on the bottom, they expanded during phase two. The ones on the top, as you remember, they did not expand. The cell phone, as I had figured, we had some very irregular expansion there. I mean, it's just basically damaged petals that got bent back in the process of going through the gelatin. So that's considered a failure. So the cell phone failed in phase one and phase two. Now the sheetrock, the particle board in phase two, you can see on the top, phase one, they expanded nicely, as we saw. And on the bottom, the cavities are full of that brown material from the particle board, and they did not expand when they were up against the gelatin like that. Same thing with the sheetrock. You can see the white gypsum in the bullet's cavities, and they also failed to expand. So moving it up against the gelatin changed everything. We went from failure to expand to expansion, and vice versa. This is a JP3 retest and JP4 retest. So the same exact sheetrock that was shored up against the gelatin, once again, I moved it 7 feet away and fired through it again to see if I was going to get similar results as I did in the phase one testing. And I did. So all these were retests of the phase one testing during the phase two testing. And I got my expansion as I did the first time. So as far as discussion conclusions, bullets that failed to expand were the JP1 series, the wallet, placed up against the gelatin, the cell phone up against the gelatin, the particle board placed up against the gelatin in the 3.1 series, the sheetrock in the 4.1 series placed up against the gelatin. Are we starting to see a pattern here, right? The cell phone inside the denim pocket, 7 feet, and the JP 2.1, as I said, was a damaged bullet, so that also failed to expand. And then we have the denim that was up against the gelatin, where the bullet went through a seam and got all that extra material in it. The JP2 series failed in both locations, up against the gelatin and 7 feet away. And I'm attributing that to the damage to the cavity from the striking that hard surface of the Gorilla Glass. And it's the only one that had the same results when it was 7 feet away and also shored up against the gelatin. So that's easy to attribute to damage to the bullet. JP 1, 3, and 4 all expanded when there was distance between the target material and the gelatin. And 1, 3, and 4 all failed to expand when they were shored against the gelatin. So the free flight of these bullets allowed some or all of the materials to be vacated from the bullet's cavity. So after, when it was 7 feet away, after it passed through the those materials, then it was able to empty the cavity out, perhaps, and that's why they expanded. So I wanted to do something with the data here to quantify them. Basically, what I did was I measured the maximum width of the expanded bullets and divided it by the maximum unexpanded size, which is 9mm. They're all 9mm bullets. So that would give me an expansion ratio. So for example, if I had a 15mm bullet, that's the measurement after expansion, and I divide it by the unexpanded bullet, I have a 1.7. So the bullet expanded to 1.7 times its maximum unfired diameter. So here's what these look like. The JP3 series, those expanded. So we have expansion ratios of 1.6 and 1.7 for both of those. The JP4 series, the same thing, 1.6 across the board for those. They're all very, very close in size. The JP 1.1, same thing. We have 1.7s and 1.6s, right? Those are my expansion ratios for them. The gelatin control and the denim control, here's where you start to see a difference. The gelatin control, this is from the phase 1 testing. I have a 1.7 expansion ratio, but the denim is only a 1.3. Okay, and we're seeing the same thing with the phase 2 testing, the 3 shots through the gelatin. We have much different expansion ratios than the denim, 1.6, 1.7. Right, here's the denim in the phase 2 testing, 3 shots through the denim, 1.4, 1.4, and of course that third one that failed to expand, it's not applicable. Right, the JP3 and the JP4 retests during the phase 2 experiments, those were 1.6 and 1.7 respectively. So when we put them all in a bar graph, you can see what that looks like. The JP3, the retests and the original expansions are all very similar. We either have 1.6 or 1.7 expansion ratios until we get into the denim, where we have significantly lower expansion ratios. So that's what that data looks like. So the causes of jacketed hollow point bullet expansion failure experienced in these experiments were the cavities were obstructed by intermediary target materials, right? As we saw with those shored targets, everything that was shored against the gelatin, we saw there was material in their cavities. We also saw the damage to the cavity that prevented expansion. That was from the cell phone shots. And then also that one bullet that was destabilized, right? That was kind of outside of the parameters of these experiments, but I just wanted to induce a bullet destabilization. Velocity loss was not a factor in any of these failures. These are my references. And I want to thank you all for your time. And it's been great working with everybody here. I wish you all the best of luck.